I think, but that means that like, let's just say, um, inbound packets would be like double tunneled, right? Or is that not true? They would
Mm.
never.
So,
Okay.
yeah, we do have scenario that sometimes some things are double tunnel, mostly if this is coming from SLB load balancers. So if
Okay.
traffic coming from load balancers, the load balancers add additional NCAP on top of what original packet can be. So in this case, there is basically one scenario of when it's coming from the inbound load balancer, then the traffic will be in additionally NCAP.
So
What
like,
about VNet to VNet peering, Mike? Is that also double NCAP?
No, VNet to VNet has a single NCAP, right? However, there is a scenario when the destination is actually inside the VNet, but the destination is internal load balancer entity. So in this case, we basically NCAP this as VNet traffic, but because the destination is not an appliance, the traffic just gets routed through the load balancer max device, and this load balancer max picks the destination, adds the double NCAP, and then forwards to the specific destination.
Yeah. So I think we're missing one drawing in all our pictures. It is possible, even not even going to a load balancer, it's quite possible to go from one appliance to another appliance where that VM is connected.
But I want to emphasize that basically load balance is more like software load balance, like load balancer entity of handling traffic from the internet, right?
Yeah.
That will definitely will have in P4 model. I'm not quite sure the current P4 model started talking about this or not, but this is like how we handle internet. So this is not the VNet to VNet traffic. The VNet to VNet traffic, there should be no kind of second NCAP based on I understand, but we should support it because sometimes we are going through some additional like for private link, we do basically NCAP this through some appliance.
Are you seeing it in here?
I did see it in there. I don't remember which file. Like maybe in that inbound or outbound file.
Mm-hmm.
Is the word appliance in there?
Yeah, there is one in outbound, I think.
What print?
There is one in the outbound, the appliance keyword.
So Prince, the outbound appliance, is it the appliance like NVA, or the appliance is referring to something different there? Do you recall?
No, I think this one is basically the appliance header, like the current appliance which will be used for the encapsulation and yeah.
But I think it's my understanding, right, that the endpoint, like the NIC that's on the server of the VM will add an NCAP to get the packet to the appliance, right?
If appliance, you mean the specific card that on which the P4 pipeline will be running? Yes.
Yes. Yeah.
That's correct. But the customer traffic that the customer originates, this traffic is usually not NCAP. Customers usually originate traffic
sure.
fully
Right.
raw. Yeah.
Right. Out of the VM, there's no NCAP. There's no tunnel, right?
Mm-hmm.
But out of the NIC on the server, there would be this VXLAN NCAP that would get it to the appliance, right? And then the appliance would do like an inbound or outbound route lookup. And like I also had a question about that inbound route lookup. I saw, I think in the P4 code that the inbound route lookup is just based on like a lookup of the VNI in that VXLAN header. And I wasn't sure if that was correct or not. Like let me put it this way, like I see stuff in the P4 model that like is not documented in the spec. And so like it's unclear to me, like for example, in the spec, I don't think I saw anything that explains like how the inbound route lookup is performed.
Okay, that's good observation. So we need to add this to the spec for the inbound route lookup. Yeah.
But we've done, Christina's working on that document. That's a fairly big document that's being written for the forwarding piece.
Yeah.
Christina? I mean, she's almost done. I mean, it's gonna be done by Wednesday.
But
And so
does this
you
document
are-
has inbound, Gerald? Because I think that time we were discussing outbound. So maybe good observation that John mentioned that basically there is maybe in this document there is no inbound specified. So we still need to potentially add some section about inbound.
Because remember the last meeting, Mike, you said the inbound was very simple. Was the left-hand side and it was just the tunnel.
Oh,
itself,
but this
and
is- but
and
this
the
is the-
right-hand
maybe-
side did everything else.
Yeah, but maybe because the left hand side is just the tunnel, right? So left hand side
Mhm.
is from the VM to this is just like a pure tunnel, like one single tunnel that basically from the VM every single packet goes to the appliance and then goes back, right? The entire processing, the entire thing that P4 pipeline specifies or mostly specifies will be the right hand side, which is basically the once this kind of raw packet from the VM gets through the rules. What we are doing with this packet, depending how which destination is going, this is the outbound routing, right? And also when the traffic comes from the right side to the appliance, right, this inbound, and I believe, Gerald, the inbound we also need to document more
Right.
clearly.
Yeah,
Right.
we have that documented here that we need to have this populated further.
Okay.
Yeah, the right side inbound we need to populate definitely, right?
Mhm.
So,
we haven't
should
show
we
item.
not put it in the, should we not put it in the same document though, that Christine's working on?
Yeah, so I think what we can do, we can release the Christina's document, right? Because it will specify the right hand part of the basically routing and the outbound, and then we can follow up with the update to this document. It will also specify the inbound on the right side. And this should be then fully in sync with the P4 model, I think.
Yeah. then we
Okay.
need to update.
Because I think P4 model may went slightly ahead of the documentation.
Correct. it
Okay.
did.
Okay. So you think the P4 model is actually correct, but it just hasn't been documented about how to do the.
No, we think the other way around. It went before the documents were done.
Okay.
So the one that Christina is working on right now, which is based on the recording that Michael did, that is explaining why the lookups are more complicated than just the longest prefix match.
Okay.
And in that document right now, I think what they're saying is that's the outbound. We will also document the inbound on
Okay.
the right-hand side in the same document. Once we're finished with that document, I know that the outbound will be done by Wednesday. Maybe we need to go and examine the inbound. Then we will issue that document, and then the P4 model has to be updated with it. There's a lot of detail in the document on how to process the forwarding, because it's not, it's like we talked about, remember last time we said, well, it could be going to another VM, but it also could be going to a load balancer. It also could be going through ExpressRoute, or it also could be going to the internet. That's all done. That's never been described clearly on how that is done and how you redirect, to appliances, software appliances in between and all that kind of stuff. So we're almost done with that.
Okay.
And I think you're just saying, okay, but that's the outgoing. Now, just make sure you document the incoming from the right-hand side as well.
I'm also happy to get the outbound documented more clearly too. So I mean, we'll be happy to get both direct.
I think Christine said you're going to be sort of at least draft form on Wednesday, right? Tomorrow.
Okay.
So Christina is right now showing something. So is it already published? Maybe this is the part.
This is the PR, and it's in draft form, and I'm almost done. I just need to do the on-prem and the private link part at the bottom. But so far we've done explicit, we've done paired VNet using mappings, direct communication between subnets, adding a firewall hop, filtering a default route, trusting some internet traffic but not other, and set on-prem route to express route. I just need to pick it up right here and finish it. I've been doing it at night. So yeah, this is it, Michael.
Cool.
Okay.
Yeah. So typing as fast as I can. And Michael and Michael
And it-
Miele.
Yeah,
Right,
yeah.
and then other people have to type as fast as they can into the P4 model.
Yes. Like it.
Yeah. Yeah.
So one other thing that I saw in the document was that I think most of the text describes VXLAN NCAP, but the diagrams show GRE.
Which diagrams at the
So
bottom?
yeah, so we actually support both NCAP models. So there is still some scenarios that are not yet switched to fully VXLAN.
Yeah, like this diagram, right?
Yeah. So to be honest, there is still some scenarios that are still using GRE, right? Like load balancer, those kind of stuff, they are still using the GRE, right? VM to VM inside the VNet, right? This one is using both. It used to be using GRE. Right now we switch to VXLAN. So basically, we are in the process of switching everything to VXLAN on our side, right?
Yeah.
But we haven't yet updated every single device that is in the path of all the different types of communication yet. So for example, VM to VM communication in VNet, we are able to switch to VXLAN. Some of the other communication, which is for example involving MAXes are still using GRE. The SLB MAXes. So in this case, the protocol will also need to support allowing to NCAP with the GRE because we are assuming that we will not be able to transition like not earlier than a year or so.
And
So
even
all
this
the protocols to
this
VXLAN.
is a requirement of Dash that like in some cases is GRE, in some cases is VXLAN.
Yeah.
well, I
think-
also
For
think Dash is not
long-term-
for Microsoft only. Anyways, I think other clouds might use MDGRE, so you should be able to handle both.
True. For the long term, from Dash perspective, do we just suggest VXLAN or do we want to include NVGRE as well?
I think from Microsoft's point of view, long term it would be VXLAN, but I don't want to limit it to Microsoft. We should just be able to handle both.
Yeah, and also if we do only VXLAN, right, then there may be some scenarios which you right now will not be able to enable, like private link, for example, Gerald, which is still not on VXLAN, for example, right? And this just means that we cannot use those devices for GA for actual production payload.
Yeah,
For some of the
so
customers.
I think our requirement is both, and I'm pretty sure that other clouds would have both. So
Okay.
just say both.
Sorry, I'm scrolling. I'm just doing some looking while we're talking. But yeah, I know that we have VXLAN and GRE in here. But good catch though. Good catch, John, on the drawings.
And so, all right, so I mean, I guess like the, the SAI APIs and stuff would like, would configure, which type of NCAP would be needed, right?
Yes, have to.
Okay. That was my short list. I didn't have anything else.
I have one follow-up, but if others,
Right.
go right ahead.
Go ahead, John.
So this is a follow-up to earlier in the conversation. I know you want to close this out, so we were talking about the fin followed by ACK, maybe wanting to match up sequence numbers. What if an implementation saw a fin and set like a 5 or 10 second timer, and regardless of whether an ACK came in there that time, closed it, deleted the state? Is that acceptable or is that unacceptable?
I actually think that's what VFP does. So it could be because if you didn't see the acts in that time frame, then obviously there's some other issue going on. But I don't think we could tell. You'd have to test both cases. So that means you'd have to test. The testers who are writing test cases would have to write the test case for receiving the acts or after a short period of time. And that's the one that we said when we talked about earlier. We said that's extra code that's going to have to exist for something that's almost never going to happen. Do we really want it? Is it really useful?
Gerald, maybe I didn't understand that part. So
if we have an absolute timer started when we have get a fin or RST, which is 5 to 10 seconds or whatever is the time decided. If it was a normal behaving connection, of course, you will expect to get that acknowledgement and all that, pending acknowledgements in that time.
Yeah.
I didn't understand the later half.
It's not explicit, right? If you just wait for the acknowledge. So in other words, 99.999% of the cases, you're going to get the ACK, right? And it'll close. So now taking a different case on top of that and saying, well, we'll ignore the ACKs and we'll just use timers. Well, timers are pretty expensive. Like, do you really want the expense of a timer on every temporal?
It depends on the
fragment
implementation. It might be
connection?
cheap for us, for example.
Hardware, sorry, go ahead.
I think the issue is actually that it blows up your flow table, right? I mean, like, if you have very short-lived TCP connections, like stock quotes or something, like very short-lived connections, you're gonna like keep them in your flow table for an extra 10 seconds. And so, at high connection rates, like your flow table might be full of just like these kind of zombie connections waiting to be aged out.
You're not gonna keep them in there if you have an ACK. I mean, you're gonna get rid of them.
So I think that they're suggesting an alternate.
Just 1 second, maybe I'll try to answer both of them. One is about the expense of timers versus sequence number on hardware design. So, we debated a whole lot on that drill, and actually the expense of timer is a lot less than it is for sequence number. And we do have a calculation and we can probably look through it. The timer state is more of, because, it's like a thread, typically just like how it would be in software, a hardware thread. You really are not, it's a sweep timer kind of thing, right? So it's not like you're spending too many bits for every time that you sweep that you need to manage a huge number of state. Plus, of course, you have to have the complete state as well, which you will, check against, and there are ways to solve that by double caching and stuff. About the flow cache, you having a large number of like outstanding flow cache, as long as your cache is, doing the right thing with respect to, aging out, to backup memory, or not removing, but I'm saying like, pushing to your backup in an LRU kind of mechanism. If you're not getting anything, it will get pushed out, right? So we don't really worry about that it is going to hog your cache, because, it is not having any active stuff going on it, right? So that's not.
So I think that we talked about this previously, though. We said that if there's a timestamp there, that we can just have a background task getting rid of temporal flows that are just sitting around. Why wouldn't we just do that?
Yeah, yes. So
we discussed before. So it's sort of like a timer, only it's really a timestamp that's there, such that background task can sweep through and clean these things out, right?
Exactly.
Is that what you're suggesting?
Yeah, so it's very similar, the implementation, and I mean, there is a very clear advantage of doing it that way in hardware versus the sequence number tracking. So yeah.
No, but
so are you saying
there's a trade-off? There's a trade-off, right? The trade-off is that you will not remove that entry from your flow table for 10 seconds, whether the ACKs came or not.
No, but that is as part of your absolute flow table, which is split into your on-die cache and backup. So the LRU mechanism would push it to back because there is nothing.
You're talking about an implementation detail of your hardware, right? That maybe other hardware doesn't have. You're talking about like caches and stuff.
I mean, sorry, John.
No,
I think John is talking about the DDR size is going to be 10 seconds longer times number of flows. That's what he's talking about, I think.
I'm just saying the flow table in general is going to have to. Those entries will remain for that 10 seconds, and like at very high connection rates, your flow table might just be full of connections that have actually ended, but because of this 10 seconds, they're still in the flow table.
Yeah,
Right, but we
flow table is
also,
always two parts, right? Flow table is your working set of flow table and your total flow table, which is all your connections. And I'm pretty sure like there is a well-defined, I mean, there are three parameters. One is the rate of flow additions that you want to support. And, B is your working set of flows, which also is decided by, the rate of flow additions that you want to support. And then the latency to your backup, which is your complete millions of flows, right? So I'm really confused as to why do you think that this will blow up your flow table? It is in, you're designing the system for millions of flows and you're designing it for.
Most TCP connections will be well below 10 seconds of lifetime.
Yeah, so I mean, that's up to the timer value that you want to set up, right? It should be programmable.
it's a
Of
heuristic value
that's-
probably. Yeah. And if there is an ACK, of course, the flow information will be wiped out immediately. And the absolute timer could also help with all the floods and related attacks, right?
Hey, Christina,
that
can
there were
you,
the-
Christina, can you write down that we haven't mentioned NACs in the fragment stuff either? So I just take that as another action. We got to actually write something on that. The
Haven't mentioned
behavior of a
what?
NAC. NACs. We haven't even mentioned it in anywhere in our documentation.
Yeah,
And guys, I think that what you guys are talking about, there's no wrong or right there. I can tell you that VFP uses a timer and they don't use they don't actually wait for the act. That doesn't mean it's wrong to actually close it out. I think it's faster to close it out with the acts. Absolutely. I would say that given that we use more Intel's method today of like, we just actually wait a few seconds before we close after we see a pin. I think there's precedence for it. So you can't say it's wrong. It works for us, but I would say that optionally closing it out with the fin ACK is more efficient, and maybe we put that down as an option.
Yeah, the only so Gerald, and that is something we do support, that you can close it out. You can make the timer to be something which is like immediate 0 on a FINAC. The question is about knowing that you just counting the FINAC then, right? Like you have got it from both directions or whatever, right? So.
But the thing is, we just don't want to get the timer wrong, because if the timer is wrong, like people are going to err on making it too long, because you want the connection to close down properly.
Right.
In which case means it's not really as efficient as if you added this immediate withdrawal of a FINAC ACK, right? Because nothing's more efficient than that. There's nothing more coming. You don't need to wait anymore.
Right. And if, in terms of efficiency to close the connection down, you're right, Gerald. But in terms of implementation, I believe, there are trade-offs, and I
think I'm okay with actually doing the timer. We do it, so I can't like tell people that that's how VFP does it. So I think that we can go with that, but then optionally include the language that if you include the further action of tracking the acts, you will close down connections quicker. And if you can do that and it's no problem in your implementation, guess what? When we go to test it, it'll just be a little bit more efficient.
Well, but hold on a second. Take the hero test.
Yeah.
I don't know, 5 million connections per second of TCP connections, right?
The hero test, well, they literally, hero is a fake test. So we'll do, when we do a connection in a hero test, we send 6 packets. It goes up, it goes down. There is no time between. So it's literally 6 packets in a row.
I understood, but you'll get the 6 packets, and then that resource, that memory will be consumed for 10 seconds, right? So
no, remember the hero test has a 1 second timer. So the aging is 1 second. So everything will be gone in 1 second anyway. We don't have a normal aging timer in a hero test. It's a 1 second timer.
Mhm.
So that's why we don't have anything straggling.
So there's something like sort of inconsistent here, okay? Like if the hero test needs to do 5 million connections per second with a 1 second aging timer, okay. But then like in deployment, you need to do 5 million connections per second, but it's okay to have a 10-second like
That's because that's a different test. So hero test is how we dissect your implementation and find out how good it is. The other tests that we're going to have that go beyond that are going to be more realistic to the actual what goes out into the field. Hero test is to break you. It does tell us which part of the design is the weakest. And then that is so there's 3 parts to it. There's a hero test, then there's going to be what we conceive is going to be a more of a how we're going to set the parameters in real life kind of test. And then there's a conformance test, and the conformance test will test for all kinds of things. The hero test only did one type of testing so far, which was trying to break the unit and find out if it's, for example, if they can't age in a second, it's because they didn't even, they're doing it in software. And we can tell like literally right away that they're doing that in software. Or slow, we'll call it slow path because some people are all software, but we'll call it slow path. And there's no hardware accelerator for it. And that's why the hero test kind of tries to break things open. That's why we round robin packets in the background, 1 packet at a time, round robin. Why? Because we know there's caches in NICs and we want to break them. We want to see where they break. And so that test, which you haven't seen quite yet, is like where you say it's going to be a round robin of 1, then it's going to be a round robin of 8 packets in a row, round robin of 60 and 32. Why? Because we know there will be implementations out there that fail the 1 packet round robin, and we want to find them and find out that we broke them and where they don't break, and it goes on and on. So the hero test is more or less trying to help the buyer figure out where are the strengths and weaknesses of a design. But as part of that, the hero test is not done. We are talking about adding more of the real timers into the test so that we follow it with like a more of a real life scenario, and also the conformance, meaning that there's so many ways of cheating a hero test. Just say allow all, you're done, you're good, right? That's like total cheating. But so it would be backed up with a compliance test, which means that every rule will have been inspected.
So Gerald, is the 5 million connections per second a hero number or a real number?
No, we use that in the field today.
Okay.
But in the field today, we will have timers set properly.
And is the 50 million flow entries like a real number or a hero number?
50 for a card?
50 million flows.
So we never specified 50 million flows. It's more like 16 million flows.
I think
per card per 200 gig.
It's
so
right
if you
there.
have
I think Christina's pointing out it says 50 million.
It shouldn't. It should be 16 per card per 200 gig. So if you have a 400 gig, then that's 32 million.
16 million per.
And if it's 800 gig, it needs to be 64 million.
Okay.
So it's all per 200 gig.
Okay, so that number is not correct.
No.
Okay, so because my concern, like, take the 50 million. If 5 million connections per second is a real number, and your flow table is, and you have, let's just say a 10-second age time to age out connections that have ended, like your flow table will be completely overwhelmed by flows that have been aged out. Right? I mean, that's the point I'm trying to make, is that I think if you don't do the sequence number tracking to end the connection, then your flow table will have to be like many times like the size in order to be able to handle just, flows that are just waiting to be aged out.
No, you might be right, and here's why. Even BFP doesn't do that today, but BFP doesn't do very many connections per second, so therefore they wouldn't have had this issue.
Right.
And we're trying to do something that is 100 times faster, so that's why this issue is now new coming to bear. So now I'm thinking you're bringing up a very, very good point. There's a difference between, you know, doing say 50,000 connections per second and doing 5 million connections per second.
Right, because at 50,000 connections per second, you can afford 10 seconds worth of like sort of zombie flows in your flow table. But at 5 million connections per second, that number explodes, right? Like you.
I think you're bringing up a good point. And I think people have not seen this point before, because if you look at implementations today, they don't do 5 million connections per second. That's why they've never come across it.
So, Gerald, I mean, the time you keep it active, like the timer, is of course a parameter, as you mentioned, you know, that you have to decide depending on the scale of your the connection add, as well as the total connections that you're going to support, as to like, you know, what is a good absolute timer if you're going with the timer approach to kind of keep them alive. But the one more question I have, the CPS here is 4 million plus. So is that 5 million is what you're saying, Gerald?
So these numbers are arbitrary because it's whatever you can do. The thing is that depending on when you started testing, so let's say you test a VNet and you say, I've got a rough VNet, I kind of did that, there's no counters, I didn't handle all the different forwarding techniques because I didn't know them. And, you know, if you do that in the beginning, you might reach a higher number. And then what happens is, as you actually implement everything that you need to do, it will, you know, we see it go like 3 million plus. It won't be the full 5 million. So 5 million is not a real number. It's whatever you can do. That's why the hero test has to be crafted, because you have to figure out what your highest connection rate is. And then your background traffic has to be against that. And so those are arbitrary numbers. Right now, what we see is we can easily achieve 3 million plus, even with the full HA, with everything turned on. And so when you hear numbers being thrown around, it's because, okay, did you have HA at that time? Did you have all the counters at that time? Did you have the right, you know, all the forwarding at that time? And if you didn't, of course, your number is going to be higher. Or did you really do rules, or were you just doing tuples, which is a totally different thing. That's like a firewall filter. It's not really a set of rules. So ignore, those are guidance numbers. Just the way, but we do have some experience. So for example, 16 million connections, don't trivialize that. That's going to take up almost all your 32 gig of memory. So it's not like we have experience enough with that now that is the biggest memory consumer, is the actual flow table.
Right.
Not the policies, not the policies that you plumb, not even the forwarding tables, but the actual flow tables dominate the memory. So that's why, you know, if we said, for example, 50 million, first of all, it wouldn't fit into 50 million. We know from practice would not fit into 32 gig, right? And so what ended up happening is we started at 16, just to give you some background. We got 16, but then we said, well, what about HA? Well, HA is going to need, you know, twice as much memory because we got to plumb like all the rules from both sides of the HA platform, blah, blah, blah. And we ended up saying, and when we went through the memory calculator and actually implemented it, we only ended up with about 8 million flows. There's actually 16, but only 8 million are being used because of the HA function and how it was implemented. So the numbers will come down as you start to use the feature set as a feature set wide. You know, everything kind of comes down. But where we settled, even with HA, we ended up with on a 200 gig with a 32 gig memory, we were able to support the 8 gig flows. The 16 is a requirement in the VNet test because VNet doesn't include HA. And if you couldn't do 16 million without HA, you can't do 8 million with HA. So that's kind of some just background of all the stuff we learned over time. So don't get too,
Caught
you
up.
know, caught up in the numbers. We know we would love over time as memories get bigger and cheaper and denser and everything that it would be nice to have larger flow tables. And we know what can be done today because most things are done in DD4 today. Tomorrow is DDR5. That gives you, allows you to have, larger than 32 gig and stuff like that. So we can have bigger tables, but like we're kind of being realistic today with that. And we'll publish more numbers as we, as the hero test is published, we can kind of give a little bit more guidance, but the hero test is still being written and analyzed today by Excite and others, and including ourselves. So not ready to give the final numbers yet.
Makes sense.
So-
Just one more clarification. So if the FIN-ACK is sufficient to kind of terminate a connection immediately, I'm not sure why still would we do, I mean, so this is
because there is a reason to time. I don't think you can get rid of the timer because what if the
no,
well,
timer
okay.
remains, timer remains.
Yeah, timer
what-
remains because that would be faster than the age timer, which we know will be like 3 minutes or something. It's like absurdly
correct.
large, right?
Right.
We don't
Yeah,
really
so-
want that.
Yeah, so the 4 timer way, which I think is the right model, at least for what we're doing, is you start the last, getting done kind of timer at FIN, but then you make the timer to 0 for immediate termination as soon as you see the FIN-ACK. Right, so I think that's the model that seems to work.
Yeah, I think that's the ultimate model. I think
Yeah.
we need to go there because of the connection rate.
Yeah.
Agree. Yeah.
Does anybody want to take a stab at writing that down, or do you want us?
I don't want to write that down because I don't necessarily agree. I think that tracking the sequence number is a way of removing the flow more quickly.
I thought that's what she just said.
No, I don't
You
think
do that, but then
Not,
if you
not the
if-
sequence
if-
number, using the FIN-ACK as the last timer state for a flow, FIN being the third state of the timer and FIN-ACK being the final. I can write this down, Gerald, because this is the flow that we're using, but yeah.
Yeah,
I'm
Sure,
not.
honestly.
There's a sequence number here, but I'm not sure what the difference is. If you're terminating on the FIN-ACK, then in order to know that it is the ACK associated with the FIN, you had to track the sequence numbers. So,
Well,
Unless the ACK for the fin does have both TCP flags set, and you can rely on that.
yeah,
sure,
which is
sure.
the case. Yeah. Yeah, so I'm not convinced we need the sequence number here. I'll write it down and we can review it.
But remember
Basically-
that when we remember, everybody remember, we are a bump in a wire. We can't control what the endpoints do. So they're going to terminate the way they want to.
Right.
So don't count on the FIN-ACK being the same packet.
Being the same packet. Sorry, maybe I'm missing something.
Yeah, I thought I heard somebody saying a FIN-ACK in the same packet, which is not possible.
No. FIN and then a FIN-ACK.
Oh, okay.
Yeah. And that's the flow, and I could probably write it down, and we actually have a flow written down. I'll probably just share that.
Okay. Yeah,
Maybe
that
we
would be
can share
great.
it with Christina and.
Yeah. I will. Yeah.
I just put
So-
I put the doc in the chat window, and you could just do a PR on it, or you could share it with me.
Do a PR because I think John can also comment on it. So let's have the debate like we normally would. In a thing like this, you do the pull request, and then people can chime in and they can put their comments, and then we can. I think this one's worth finally closing out. Closed, right? So we didn't close it out today, so we'll have another chat after doing a pull request and having more comments, and then we'll try to close it out for good. But I think a lot of good points came up here. Even, that one I didn't really think about myself. That being 100 times faster does bring in new consequences.
If you need help, just call me. If you need help doing the PR, adding John as a reviewer.
Yeah.
Oh, okay, sure, Christina.
Yeah.
Yeah, we'll just be mentioning the absolute timer and
Yep.
usage of FINAC to close out without using the sequence number. And I will need your help to add John as a reviewer.
Yep, pretty easy. No problem. No problem. There's just a little gear usually in the top and it says reviewers and then you click Meetuloom, Middleloom. But sure,
Okay.
I'll help you.
Okay, we'll try previously. Sometimes it didn't work, so
That's
we'll
fine.
try.
I will help you if you need, yep.
Would be, I really want to close this because in the end, the behavioral model doesn't have to be efficient like how it's written. So, but I do want it to be up to date. And we got all kinds of stuff that we need to do to the behavioral model, from the forwarding, both inbound, outbound forwarding, plus to finish out this stuff. And so, Christina, I think it's only Tuesday. Why don't we meet again Friday and try to close this? We do the pull request today from Intel side, comments by Friday, and then have another short meeting, maybe a
Okay.
half-hour meeting, to see if we can all agree to how to close. And that gives John some time to make his comments again and arguments on this. I'd like to, if we could close it by Friday, otherwise we're delaying, anybody going up and doing more work on the P4 behavioral model because they're afraid that we're not settled.
I can set that up.
Yeah, okay, that
No
sounds good.
problem. Okay, sounds good. Anything else, Andy? But nope. Thank you guys for your time. We're actually 3 minutes ahead of time.
Thank you.
Yeah,
Bye, guys.
Thank you
okay.
so much.
Appreciate y'all. Thank you.
Great
Bye-bye.
discussion. Bye.
Bye-bye.